So in this video, what we're going to be learning is how to take the integral with respect to y. And it's very simple. So far, what we have is some function that looks like this. And we've had a rectangle here. And that rectangle has a width of dx and a height of y. So we've been taking the integral with respect to y dx. So we plug our y value in there, and then we take the integral. Now what we're going to be doing is looking at the function this way. So our rectangle is now turned horizontal. That gives us a width of dy, because that's now on the y-axis. And the height would now be an x, because that is on the x-axis. So we end up getting this integral of x dy. So what we're going to be doing now is basically rotating our graph and looking at it. And here's the reason why. So here's our question. We want to take and find the region bounded by the y-axis, the line y equals 1, and the function for the fourth root of x. And so that gives us this region here. So you can see it's not the area under the curve. That's not this. It's not the area under the curve with respect to the x-axis. We are now going towards the y-axis. So that means we need to make our rectangle horizontal, not vertical. That means that our width here now is along the y-axis, so that's dy. So if we're on the y-axis, this would be the change in y. That's what we're getting here. And then the horizontal now is along the x-axis. And so that would make that one x equals. So our rectangle looks like this, dy and x. So if we're going to add up all of those rectangles, we're going to get the sum of all of those rectangles with an area of x dy. So let's take a look at this in Desmos, and you'll see a little bit better picture of it. So I'm going to run all of the rectangles through. So this is all of our rectangles. They all look like that as it goes through our function, right? And so you can see it's the area under the curve with respect to y. It's just rotated. So if I move that little rectangle back to somewhere in the middle, you can see the dimensions of it are our change in y's, because that's on the y-axis. And then the height now is the x, not the y value. So our areas become x dy. So the height, or the length, however you want to look at it, is x, and the width is dy. So each rectangle will have an area of x dy. And then when we take the integral, it's going to add up all of these rectangles. So like this, it's the sum of all of those rectangles that we get. So now what are these dimensions? So all you have to do now is go, well, that's x equals. We know that this is our function y equals. So if we now solve it for x, take it to the power of 4, both sides, you get x equals y to the fourth. So now if you come down here and plug that in, we get y to the fourth is the height, dy is the width. So this is just height times width. And now we just need from where to where. So if we go back to Desmos, we follow it along the y-axis, you can see it starts at 0, and it travels all the way until y is 1. So our values are from 0 to 1. So it's really just a rotated version of it. Since we're now doing it instead of respect to x, we're doing it with respect to y. It's starting y value to finishing y value. The width is dy, and the height is x. The letters are all switched, which is honestly another way that you could do this. You could just go back, switch all the letters, and that just changes your axes. But now we're going from 0 to 1, where they intersect, of y to the fourth dy, and that will give us the area under the curve with respect to y. So this is now 1/5 y to the fifth. Plugging it in, and we get 1/5. So what is the area under the curve? That little region right there, 1/5. So you can see all we really did was just switch all the letters to get what we needed. So if you see that your rectangle is vertical, the width is dx. and the height is y. And if you see that your rectangle is horizontal, the width is dy, and the height is x. And so now everything, when you write it, will be with y values. And everything here will have x values. Meaning this is our starting x to our finish x. And this would be our starting y to our finish y. And then you may be saying, well, that's an x inside. Yeah, because when we solve our function, we solve it for x, and then when we plug it in, it becomes a y. Just like here, this is y, but it is always in terms of x. So when you take the integral, it's all x's. When you take the integral of y, it's all y's. This is our first y, ending y, y to the fourth, dy. These take a little practice, but you really do need to get used to doing it both directions, having a vertical rectangle and a horizontal rectangle. That's all these integrals are, is adding up all of those rectangles.